Alright, this is the new video for assignment 15. Sorry I messed up the first one. Try to get this done as quickly as possible so I can get it out to you. Dealing with segments and circles for geometry. First rule, dealing with these first four here. The first rule says that when we have two chords that intersect each other inside a circle, then this part of one chord times the other part of that same chord should equal the two parts of the other chord multiplied together. So here it's going to be 2 times x should equal 3 times 6. 2 times x is just 2x. 3 times 6 is 18. Divide both sides by 2, and you end up with x equals 9. I'm going to do number 3 next because it's right below there. Same idea here. This part times this part should equal this part times that part. So 6 times x should equal 8 times 8. Well, 8 times 8 is 64. 6 times x. We divide both sides by 6. Grab my calculator. 64 divided by 6. And I end up with 10.6666. And you got to start to know that that 0.6 repeating is the same as 2/3. So our answer here, this is number 3, is going to be 10 2/3. If you wrote 10.7, I wouldn't throw a big fit. Next one, on this one, a little tougher. We know that this radius is 10, but we don't know this part right here. But we do know that from here to the edge is 10. So if this outside part is 2, then that means this leftover part here has to be 8. So those two add together have to be 18. So it's going to be x times x for the one chord, and then 18 times 2 for the other chord. X times x is x squared. 18 times 2 is 36. When you have an x squared and no other x's, all you got to do to solve it is take the square root. You end up with just x, and the square root of 36 is just 6. Number 4. A little tougher on number 4. We're going to take x times this whole thing here, x plus 7. So this part times this part, and then that equals this part times that part. So 3 times 6. Over here we're going to distribute this out. X times x is x squared. X times 7 is 7x. On the other side, 3 times 6 is 18. Then we take, whenever you have an x squared and an x term, you got to think back to your algebra days. In your algebra days, 3 ways, actually 3 or 4 ways that you could solve this. One was graphing. We probably don't want to do that. One was factoring, and one was using the quadratic formula. Anytime you have a squared, it's a quadratic, so we could use the quadratic formula. But first thing we got to do with this is get it in standard form, and that means getting everything on one side. We did a little bit of this during class earlier this year. So you end up with x squared plus 7x. You can't put the 18 with the 7x or the x squared because they're not like terms. So you just write minus 18. And now on this other side, on the right side, we have 0. Alright, I rewrote this on another sheet of paper just so I'd have more room, and I'm going to show you this. I'm actually going to do this one 2 different ways. I'm going to factor it, and I'm going to use the quadratic formula. This is the quadratic formula. Don't let it confuse you just because it looks long and difficult. In the quadratic formula, you have 3 variables. You got a, you got b, and you got c. The number that's in front of this x squared, the coefficient in front of it, is always your a. Coefficient in front of the x is your b. And this number is your c. So this time a is just 1, b is 7, c is negative 18. I'm going to do the factoring first here. Then I'll do the quadratic formula and show you how to do it and show you how we get the same answers. Factoring, you set up your 2 parentheses. You find the factors of the first term. This is all stuff that you learned in algebra. find the factors of the first term. What times what will give you x squared. Well, this one's easy. It's just x times x. When that coefficient out in front of the x squared is just 1, it's always just going to be x and x. Then you got to take this term and you got to find the factors that multiply together to give you negative 18 and add together to give you positive 7. So negative 18, positive 7, I'm thinking 9 times a negative 2. So 9 times negative 2 is negative 18. 9 plus negative 2 is positive 7. Those are the ones that are going to work. So in here I put x plus 9 and then x minus 2. And to check it, to make sure that you factored it correctly, you could do FOIL. All you really have to do is the outer and inner terms to check to make sure you get that middle term. Outer terms would be x times negative 2, which is negative 2x. 9 times x, which is 9x. That gives you a positive 7x. When you combine them, that's what we had. That tells us that we factored it correctly. Hopefully you remember some of that. I know I'm going over it quickly. Hopefully you remember some of it from your algebra. Then to solve this, you just split it apart. Either x plus 9 equals 0, or this other part, x minus 2 equals 0. And you solve those two. Subtract 9, you get x equals negative 9. Add 2, you get x equals 2. So those are our two answers. Either x equals negative 9 or x equals 2. Anytime you're doing a quadratic equation, you're going to have two answers. One of the things I'll say is when you graphed them last year, you did this and you figured out where, it was a parabola, and you figured out where the parabola crossed the x-axis, and those were your two solutions. Now I'm going to go back on number 4 here, and I look at this because I got x equals negative 9 and x equals 2. Well, if I go back here, this little part right here is just x, and if I put negative 9 in there, that would be saying that that segment is negative 9 units long, and that's not possible. So a lot of times in geometry, some of these answers just won't physically work. So that negative 9 won't physically work. That means our answer is 2 for number 4. Now I'm going to do the quadratic formula for that same problem. This is A, this is B, this is C. So everywhere we see A, we're going to put in 1. Everywhere we see B, we're going to put in 7. Everywhere we see C, we're going to put in negative 18. So I end up with x equals, this means the opposite of B. So B was a positive 7. Now it's going to become a negative 7. Plus or minus, this is where our two answers are going to come from, and we'll deal with it here in a few minutes. Then we got 7 squared minus 4 times A, this time is 1. C is negative 18. Don't forget that negative. It'll mess up your whole problem. Over 2 times A, which is 1. When I do this, I grab my calculator and I do all of this underneath the radical right there. You can plug it all right into your calculator just the way it is. 7 squared minus 4 parenthesis 1 parenthesis, open up a new parenthesis, negative 18, close that parenthesis, hit equals, and you end up with 121. So that 121 is all of that under that square root. Well, I know the square root of 121 is 11. So I get negative 7 plus or minus 11, getting rid of the square root. If I took the square root of 121, I get 11. Equal, or over, I can do this bottom in my head. 2 times 1 is just 2. Write it down. Now here's where the plus or minus comes in. So what you do to get your two different answers is you split this up. And you say either it's negative 7 plus 11 divided by 2, or negative 7 minus 11 divided by 2. Negative 7 plus 11 is 4. 4 divided by 2 is 2. So that's one of our possible answers. Negative 7 minus 11 is negative 18. divided by 2 is -9. That's our other possible answer. And we've already discussed that -9 won't work, so the answer has to be 2. All right, so those first 4 again, chords intersecting inside the circle. Now we go to this next group down here, and we have like tangents and secants, or secants and secants. Remember, a tangent touches the circle at one point. A secant goes all the way through the circle, but this time they're segments, so they don't actually go through the other side. The rule for this on the notes was for a tangent and a secant, you take the tangent times itself, and that should equal the outside part of the secant, which this time is 9, times the entire secant. And this is where it gets a little tricky sometimes. So what you got to do to get that entire secant is you got to add this outside part and that inside part. So I'm going to put this in parentheses, and it's going to be 5x plus 9. Then I grab my calculator and I do 13 squared. I get 169. So this over here is 169. Then I distribute out here, and that's going to be 45x plus 81. Subtract 81 on both sides. These cancel out. I'm left with 45x equals, that's 88. Divide both sides by 45. So I'm going to grab my calculator. 88 divided by 45 is 1.955. That's no special. It is sort of a special, but not one that I expect that you're going to remember or have memorized. So we're just going to round this off to about 2.0. So our answer number 5 is 2.0. Number 6, we got a secant and a secant. So you take the outside part of the secant, 6, times the whole thing, which is going to be 4x plus 6, equals the outside part of the secant, which is 6, times the whole thing, which is going to be 6 plus x plus 3. Now, before I go a whole lot farther on this, we could distribute out there and solve that. But the thing that I noticed about this problem is this and this, the two outside parts are both 6. Well, what that tells you about the two inside parts is that they're going to be the same. So we could solve this equation, or we could just say that these two in here have to be the same. So 4x has to equal x plus 3. And that's a little easier to solve. It doesn't work out every time, but when those outside parts are the same, it does. So we end up with 3x equals 3. Divide by 3, you end up with x equals 1. Next one, again, we have a secant and a secant. On this top secant, the outside part is 8. The inside part is 2, but we want this whole thing, so 8 plus 2 is 10. Just add those together, so it's 8 times 10 equals, here the outside part is x. The inside part is, or I'm sorry, the whole thing is x plus 11. You got to add these two together, add the x and add the 11. We get 80 equals, we distribute out over here, x squared plus 11x. I'm going to move the 80 to the other side because we have an x squared and an x. So we're going to have to either factor or use the quadratic formula on this. So I'm going to subtract 80 on both sides. We can't put the 80 with the other terms. So we end up with 0 equals x squared plus 11x minus 80. All right, I rewrote this, and notice that I turned it around. I put the 0 on the right instead on the left. It doesn't matter. You can switch ends. We talked about that property earlier this year, where you can just switch the two sides of the equal sign to make it easier. This time I'm going to factor this one instead of using the quadratic formula. I'll use quadratic formula on some other ones as we go throughout this. And the reason I'm factoring this one, because this leading coefficient here is a 1. And that makes it easy to factor a lot of the times. Quadratic formula, if I was to do it, works on every quadratic equation, but factoring is easier and works on some of them. and I know what this one is. So the x squared breaks down into x and x. You put those in the first spots in the parentheses. Then for the negative 80, we got to find the two numbers that multiplied together give us negative 80 and add together to give us 11. This might be a little hard for some of you because of finding your factors. I know that the factors that work here are 16 and a negative 5. 16 times negative 5 is negative 80. 16 plus negative 5 is positive 11. So in these parentheses, we're going to put plus 16 minus 5. Again, we could do the FOIL stuff to make sure that we factored it correctly. I'm not going to because I know I have it done correctly. And then you just break it apart. Either the first parenthesis equals 0, so either x plus 16 equals 0, or x minus 5 equals 0. Subtract 16 on both sides. You end up with x equals negative 16. Add 5 on both sides. You end up with x equals 5. Those are our two answers. Again, in geometry, we need to go back and check to see if both these answers make sense. And we look at this part outside here, and it's x. Well, we said x could be negative 16 or 5. Well, the length of that can't be negative 16. So our answer to number 7 has to be 5. X can't be the negative 16 because physically it won't work. Number 8, we got a tangent and a secant. So the tangent, you just take the tangent times itself equals the outside part of the secant times the entire thing, which is going to be x plus 21. I grab my calculator. I do 35 squared, or 35 times 35, and I get 1225 equals, distribute out here. That's 21x plus 21 times 21 is 441. Then I'm just going to solve for x, subtract 441 on both sides. These cancel out. You're left with 21x equals, I'm going to grab my calculator to do it. 1225 minus 441, 784. Divide both sides by 21. That's going to leave us with x. So I grabbed my calculator here, and I already got 784 in it. So I divided by 21. And that gives me 37.3333. Remember that 0.3333 repeating is 1/3. So for this one, I'm going to put 37 1/3. Number 9. Number 9, they gave us a whole bunch of stuff here that we don't need. All this stuff here, we really don't need it. I got a tangent and a secant. For the tangent, again, you take the tangent times itself, so it's going to be x times x. For the secant, you take the outside part, which is 5, times the entire thing, which you got to be careful here. The radius is 15, so that means this radius over here is also 15. So the whole inside part is 30, and we have to add those together. 5 plus 30 to get the whole thing is 35. Well, then you end up with x squared equals, I grab my calculator, 5 times 35 is 175. We don't have to factor on this one because we only factor or use the quadratic formula when we have an x squared and an x term. This time all we have to do is take the square root. We end up with x equals the square root of 175. I just grab my calculator, second square root 175. And I get 13.2. The other thing you could have done on this, we talked about radicals a little bit in one of the sections. You could have broken it down into the square root of 25 times the square root of, let's see, if we had $1.75, that means we would have 7 quarters. So 7 times 25 is 175. Then the square root of 25, that comes out. That's just 5 times the square root of 7. This is an exact answer. This is a rounded off answer. So either way, whichever answer you put would be fine with me. Next one, this doesn't help us on this, but if we know this tangent over here is 8, we also know that the tangent on the other side is 8. We really don't need that tangent over there. We got a tangent and a secant. We know this radius is 6, so this radius here is 6. That means this inside part, the whole thing, is 12. So I have a tangent, so it's 8 times 8 equals the outside part of the secant, which is x, times the whole thing, which is going to be x plus 12. 8 times 8 is 64. Here we distribute out. We get x squared plus 12x. Again, we got an x squared and an x term. So I'm going to subtract 64 on both sides. I end up with 0 equals x squared plus 12x. You can't put the 64 with any of those because they're not like terms. So you end up with that. All right, so I rewrote this on another sheet of paper. Again, I turned it around just to make it a little easier. I'm going to use the quadratic formula on this one. Remember that that's a 1 in front of that x squared. That's our a, so a is 1. B here is 12, and C is negative 64. And I'm just going to plug those in. So I get x equals the opposite of B, which would be a negative 12 plus or minus the square root of 12 squared minus 4 times A, which is 1, times C, which is negative 64. Make sure you don't forget your negative there. Divided by 2 times A, which is 1. I grab my calculator, and again, I'm just going to stick all of this right into my calculator, and you could actually put the radical in there as part of it too. I don't like doing that because of the parentheses and how it confuses some people. So I'm just doing 12 squared minus 4 parentheses 1, close the parenthesis, open a new parenthesis, negative 64. The one thing I will say, make sure on this negative you hit the negative button, not the minus button. Calculator won't understand it. Hit equals, and we get 400. This one wouldn't have been a hard one to factor. All right. Next thing is I'm going to take the square root of 400, second square root 400, and I get 20. So I get negative 12 plus or minus 20 divided by, and I can do the bottom in my head, 2 times 1 is 2. And then we're just going to split it off. We're going to separate it. That's where our two answers are going to come from. So we got negative 12 plus 20 divided by 2, or negative 12 minus 20 divided by 2. Negative 12 plus 20 is 8. 8 divided by 2 is 4. So that's one of our possible answers. Negative 12 minus 20 is negative 32. Divided by 2 is negative 16. So those are our two answers. Again, I'm going to go back and I'm going to check to make sure this segment out here can't be a negative 16. So negative 16 is an answer that won't work. So our answer has to be the 4. So the answer number 10 is 4. All right, sorry my paper printed off crooked. So this will look a little crooked, but we'll just go with it. This one, several different ways you could do this problem. We know that this part is 11. This is dealing with other rules that I talked about in the previous video. We could draw in and have a right triangle in any of these locations. All right, we really don't need to on this one. This one's pretty easy because one of the rules that we have is if a radius or a diameter cuts a chord into two parts and it forms a right angle, it's perpendicular to it, then it also has to bisect that chord. Well, if this chord's being bisected, this is a chord going across through here that's being bisected, and that part's 11, that means that part's got to be 11, and that's what we're looking for. So the answer to number 11 is 11. Again, sorry my paper's crooked. Next one, another rule that we had is if two tangents are drawn from the same point outside the circle, then they have to be equal to each other. So 3x minus 4 here has to equal 2x plus 1. And I'm just going to solve that. Oops, we get x, those don't cancel out, we get 1x. Minus 4 equals, these cancel out. Equals 1, add 4 to both sides. And we're left with x equals 5. So the answer number 12 is 5. Number 13, going back to same as number 11. If this chord or diameter, there should be a point here showing the center point of the circle. If this chord, or I'm sorry, if this radius or diameter forms a right angle with a chord, then it has to bisect the chord. So these two parts have to be equal. So 9x minus 3 has to equal 7x plus 5. And I'm just going to solve that. I end up with 2x minus 3 equals 5. Add 3 to both sides. I'm going to rewrite this up here because I'm running out of room. 2x equals 8. Divide by 2. And 8 divided by 2 is 4. So the answer number 13 is 4. Number 14. And I think number 14, we actually did number 14 on the first page. Somehow I got the same problem on here twice. It was problem number 2. It was the same as problem number 2. And the answer to number 2 was 6. The answer to number 14 is going to be 6. And the way we did that, we knew that this radius was 10, that radius is 10. So the part in here has got to be 8, and that whole thing's got to be 18. And we just took x times x equals the small part here, 2 times this whole thing, which is 18. And we solved that, and we had to take the square root. Next one, the same rules we used on one of the other problems up previously here, is if these two tangents are both drawn, if they make that ice cream cone looking thing, then the two tangents always have to be the same. So 6x minus 3 has to equal 4x plus 7. Subtract 4x on both sides. We end up with 2x minus 3 equals 7. Add 3 to both sides. I'm going to rewrite it up here because I'm running out of space again. We end up with 2x equals 10. Divide by 2. Well, 10 divided by 2 is 5. Same rule on this one. Vertex outside the circle. You got two tangents that meet outside the circle. They have to be equal to each other. So the equation I'm going to set up is 4x plus 2, or 4x squared. If I quit messing up here. Minus 18x minus 10 equals x squared plus x plus 4. I'm going to move everything to one side because I have an x squared term and an x term. So that means subtracting a 1x, that's 1x squared, subtract it on both sides. We end up with 3x squared minus 18x minus 10 equals x plus 4. Do the same thing with the 1x. And I'm running out of space there, so I'm going to grab me another sheet of paper. So I got 3x squared minus 18x minus 10 equals 1x plus 4. Subtract 1x on both sides. 3x squared stays the same. 18x minus 1x is negative 19x. minus 10 equals 4. Subtract 4 on both sides. You get 3x squared minus 19x minus 14 equals 0. That's what we want. We want it in that form. On this one, I'm going to use the quadratic formula to solve it. When this coefficient out here in front of the x squared is not 1, it makes it a little tougher to factor. That's where you had to guess and check. If you remember back to algebra, and you probably didn't have much fun with it. So quadratic formula is a little easier. This is our A. This is our B. This is our C. So I'm just going to plug into the quadratic formula here. Our B is negative 19 this time, so you got to be careful. It's the opposite of negative 19, so it's going to be a positive 19 plus or minus the square root of negative 19 squared minus 4 times put in A, which is 3, put in C, which is negative 14. All that divided by 2 times A, which is 3. So all I did was I stuck in B, stuck in B, stuck in A, stuck in C, stuck in A. Just stick in the numbers. Now I grab my calculator, and I'm going to put this whole thing in the parentheses just like it is. So parentheses negative 19, close the parentheses squared, minus 4 parentheses 3, close the parenthesis, open up a new one, negative 14, close the parenthesis, hit equals, and I get everything underneath there is 529. Then I'm going to hit second square root, 529, and I get 23. So all of that is just 23. So 19 plus or minus 23 on top, divided by 2 times 3 is 6 on bottom. And then I split it up. 19 plus 23 divided by 6. 19 minus 23 divided by 6. 19 plus 23 is 42. 42 divided by 6 is just 7, so that's one of our possible answers. 19 minus 23 is negative 4. Negative 4 divided by 6 is just negative 2/3. This one's a little tougher because when I go back and I check this, the 7 is going to work, right? Because these links have to be positive. But this time, if we plug in negative 2/3 into both of these, so if I do like negative 2/3 squared plus a negative 2/3 plus 4, we still come out with a positive answer. So this time, either one of those will actually work. So for number 16, the answer could be 7 or negative 2/3. Number 17. Again, several different ways we could do this. We could draw in and have a right triangle right here. And in that right triangle, I know that the radius is 7, so from the center to this edge is 7. Well, that means this part in here is 5, and this part is 7. So now I have this right triangle. It looks like this. This is x, this is 5, this is 7. And I could use Pythagorean's theorem. This is a leg, that's the hypotenuse. Other ways I could do it is I could use the chord thing, where if this is x, this over here has to be x, and use that part that we did on the first page. But I'm going to use Pythagorean's theorem this time. So x squared plus 5 squared has to equal 7 squared. So that's x squared plus 25 equals 49. Subtract 25 on both sides. You end up with x squared equals 24. And then all I'm going to do is take the square root of 24. Second square root 24, and I get about 4.9. Again, if you wanted to leave that in radical form, you took the square root of both sides, you could leave it in radical form and get a different answer. This next problem, I'm not sure how this problem got on here, but we'll do it because it's dealing with an arc, not a segment. If one of the rules is if a diameter is perpendicular to this chord, then it bisects the chord, so those two parts are congruent. Well, that also is going to bisect this arc. So this arc out here is being split into two equal parts. Well, if this part's 65, then that means this part has to be 65. So the answer number 18 is 65. Number 19, we got two tangents coming from the same point outside the circle, so they have to be equal to each other. So 2x squared plus 2x has to equal 7x plus 12. We got an x squared and an x, so I'm just going to move everything to one side. Subtract 7x on both sides. You end up with 2x squared minus 5x equals 12. Subtract 12. And I'm doing all this out. Usually I would not by this time of the year, because when you move something from one side to the other, it just changes the sign of it. And you got to pick up on that to make some of this stuff shorter for yourself so you don't have so much work to do. We end up with that. Alright, I rewrote this on another sheet of paper. I'm going to use the quadratic formula again. Again, when a here isn't 1, it makes it a little harder to factor. So using the quadratic formula might be easier. Negative 5 there is b, and c is negative 12. And then I'm just going to plug all those in over here. The opposite of b, that's the opposite of negative 5. Well, that's going to be a positive 5, plus or minus the square root of negative 5 squared minus 4 times 2, which is a, times negative 12, which is c. All that divided by 2 times a is 2. So we have all that. I'm going to grab my calculator. I'm going to do all of this underneath the radical. So I punch it in, parentheses, negative 5, close the parentheses, squared, minus 4, parentheses, 2, close the parentheses, open up a new one, negative 12, close the parentheses, hit equals, and I end up with 121. And the square root of 121 is 11. So it ends up being 5 plus or minus 11. That's all of this right here is just 11. Divided by 2 times 2 is 4. Now I'm going to separate it, split it up. 5 plus 11 divided by 4. 5 minus 11 divided by 4. 5 plus 11 is 16. 16 divided by 4 is 4. That's one of our answers. So x could be 4. 5 minus 11 is negative 6. Negative 6 divided by 4 is negative 1.5 or negative 1.5. Again, we're going to go back and we're going to check, see if, make sure both these work. If I stick in negative 1.5 to both of these, 7 times negative 1.5 gives me negative 10.5 plus 12. So 1.5, so we'd be saying that this segment out here is 1.5 units long, and that's okay. So the answer this time again could be either one of those. So the answer number 19 is 4 or negative 1.5. Could be either one of those. All right, these last few, some different rules here. One of the rules that I wanted to cover with these, if you have a diameter in a circle and an inscribed triangle, and that diameter is one of the sides of that triangle, then the angle across from that diameter in that triangle always has to be a right angle. So we have a right triangle here, and we can use Pythagorean's theorem. One of the legs is 5, so 5 squared. The other leg is 12. and then the diameter is going to be our c squared. Well, I'm going to look at this, and I know 5, 12, 13 was a Pythagorean triple that we talked about. So if this leg's 5, this leg's 12, this diameter has to be 13, but they wanted a radius. Well, if the radius or the diameter is 13, then all we do to get the radius is take 13 divided by 2, and you end up with number 20 is 6.5 or 6.5. Another rule, if a radius is drawn to a tangent and intersects it at the point of tangency, that's the point where the tangent touches the circle, then it has to form a right angle. Has to be perpendicular. So again, we can use Pythagorean's theorem. One leg is r, so r squared, plus the other leg is 15, so 15 squared equals, here's where you got to be careful, the hypotenuse this time is r plus 9, and we got to square that whole thing. To square that whole thing, we got to do FOIL. First, inner, outer, and last. So let's see, I'm going to write it over here. It's r plus 9 times r plus 9. R times r is r squared. So that was the first. Then the inner is this. 9 times r is 9r. Last would be r times 9, which is another 9r. And then, or not last, outer, sorry. Then the last would be 9 times 9, which is 81. So if I collect those like terms, now I have r squared plus 15 squared is 225, so I'm just going to do that. I'm doing some of the steps all at once. Equals r squared plus 18r plus 81. It looks like we're going to have to factor or use the quadratic formula on this, but the nice thing about a lot of these, here we have an r squared on this side and we have an r squared on this side. And if you think about your balance as your equal sign there, then when you take an r squared off of this side and you take one off of that side, they just sort of cancel each other out. So we're left with 225 equals 18r plus 81. I'm running out of room there, so I'm going to grab another sheet of paper. And here I'm just going to subtract 81 on both sides. 225, I grab my calculator. 225 minus 81 gives me 144. That equals 18r. These 81s canceled out. Then I divide both sides by 18. So 144 divided by 18, and I end up with 8. So the radius, this r right here this time, is 8. Same thing on the next one. This is a radius, this is a tangent. Point of tangency is B there, so that has to be a right angle. Probably run out of space on this one, didn't leave myself enough space. The legs are R, so R squared plus the other leg is 21 squared equals, we got to add these two together, and it's R plus 9 squared. Same thing that we had on the other one. So if I came back over here and I did all this again, we're going to get the same thing. So this is r squared plus 21 squared. 21 squared is 441. Equals, doing the FOIL on this, we get the same thing we just got on the previous problem. It's r squared plus 18r plus 81. Again, the r squareds are just going to cancel out, and you're left with 441 equals 18r plus 81. Subtract 81 on both sides. 441 minus 81 gives me 360. That equals 18r. Divide both sides by 18. you end up with r equals 20. So the radius in that case is 20. Again, key rules here. Triangle's inscribed in a circle and one of the sides is the diameter, then that triangle has to be a right triangle. Point of tangency, if a radius or a diameter is drawn to the point of tangency, where those two meet, where that tangent and that radius or that diameter meet, has to be a right angle. Next one, same thing here. Point of tangency is here, radius intersects it there, that has to be a right angle. I realize right away, hey, if this is a right triangle, this leg is 8, that leg's 15. That fits in that 8, 15, 17 triple that we talked about. So this side over here, that whole thing has to be 17. The bad thing is they didn't ask us for that whole side. They only asked us for the radius. And we just did a whole bunch of work there for no reason. Because if they're just trying to find the radius, they told us the radius. It was 8. So the answer 23 is 8. Now, a better question on this one might have been, how long is segment DB? Well, if this radius is 8 and this whole thing is 17, then this part outside of the secant here has to be 9. Well, it's not really a secant, I don't guess. This outside part would have to be 9. But the answer is 8 because they just ask you to find the radius. Next one, point of tangency is B, so that has to be a right angle where that radius intersects it. Use Pythagorean's theorem. R squared is one of the legs. 4.8 squared is the other leg. The hypotenuse this time is R plus 3.6. All that squared. I'm going to come over here and I'm going to do this. We got R plus 3.6 times R plus 3.6. First terms, we get R squared. Outer terms, we get, that's supposed to be a 3.6. We get 3.6R. Inner terms, we get plus another 3.6R. And then the last terms, 3.6 times 3.6 is 12.96. So now we have R squared plus, I should have done 4.8 squared also. That's 23.04 equals all of this, but I'm going to put these two together. So equals R squared plus 7.2 squared, or 7.2R plus 12.96. The R squareds again are going to cancel out, and I'm left with 23.04 equals 7.2R plus 12.96. Nothing hard about this, just a lot of writing, especially on problems like this one where there's a bunch of decimals. Subtract 12.96, but you're doing the exact same thing as you did on the other problems. You end up with 7.2R on this side, these cancel out, equals 23.04 minus 12.96. That gives me 10.08. I've already got this number in my calculator. I'm just going to divide both sides by 7.2. So divided by 7.2, and I get 1.4. So in this case, the radius is 1.4. Alright, I drew number 25 on a separate sheet of paper because I didn't have room to work it out there. Same idea. We've got point of tangency here, and this radius comes intersects it there, so that's got to be a right angle. One of the legs is R, so R squared plus the other leg of the right triangle, which is 35 squared, equals, on this side, the hypotenuse, we got R plus 25 squared, R plus 25 times R plus 25. We're going to do FOIL there. First is R squared, outer is 25R, inner is 25R, So first, if I do my arrows here, outer, maybe you had a algebra teacher that taught you the smiling man way or something. There's a bunch of different ways. If you don't know what that is, don't worry about it. 625 is 25 times 25. I will show you what smiling man, just because I don't want anybody to. So you got r plus 25, r plus 25. Instead of FOIL, first, outer, inner, last, some algebra teachers teach the smiling man way, which is you multiply these two, you multiply these two, you multiply these two, and you multiply these two, and it looks like a smiley face. So I have all that. I'm going to combine these two. That's just 50r. So we got r squared plus 35 squared. 35 times 35 is 1225. And that all equals all of this over here, which is r squared plus 50r plus 625. The r squareds, again, are going to cancel out. We subtract 625 on both sides. I end up with 600 over here equals 50r. These cancel out. Divide both sides by 50. Grab my calculator. 600 divided by 50. And I get 12. So for number 25, the radius equals 12. On this last one, we have, it says, an arch over an apartment entrance is 3 feet high and 9 feet wide. Find the radius of the circle containing the arch. You got to be careful on this one, because a lot of students think that since it looks like this, that this is a diameter in the circle, and it's not. So they're taking the circle and they're just drawing in a chord here somewhere, splitting off part of the circle. But it's not necessarily going right through the middle. It may be, but it's probably not. So what we have to do on this one is we're looking at the entire circle, but we just have some chord that we're cutting this off at. And we know that chord is 9 feet long, and we know that from here to here is 3 feet. Well, if we draw the center point of the circle and we draw this in, we have a radius. And that radius, if we draw it correctly and everything, is going to form a right angle here. So it's also going to bisect this if it forms a right angle there. So we know that these two parts are the same. This part then, if the whole thing is 9, this part's 4.5 and this part's 4.5. And then what I can do is I can draw in another radius over here. And that's what I'm looking for, is that radius right there. But I'm not going to put radius there because I don't want to introduce anything. What I'm going to do is I'm going to make this part over here x, from here to that point where the two intersect. Well, then that means the whole radius is x plus 3. Now I have this right triangle. This side's 4.5. This is a right angle. This side is x, and this side is x plus 3. And I can set up Pythagorean's theorem and solve that. Again, don't think that it's, the radius is 3, because it doesn't work that way. And you should be able to tell here, because if this comes to here, if that was the center point of the circle and this part's 3, then this part right here can't be 4.5, because they're both radii, and that wouldn't work out. So here I set it up. One leg is x squared plus 4.5 squared equals x plus 3 squared. X squared just stays x squared plus 4.5. 4.5 squared equals 20.25. On this other side, I'm going to do this sort of quick. It's x plus 3 times x plus 3 if you want to use foil and do it out so you can see it. But after a while, hopefully you get used to doing it and you figure out, all right, this is x squared plus 6x. 3 times 3 is 9, so plus 9. The x squareds are going to cancel out. Then I'm just going to subtract 9 on both sides. So I got 20.25 minus 9. I get 11.25. That equals 6x. Divide both sides by 6. So I got that on my calculator already, so I'm just going to hit divided by 6, and I get 1.875. That's what x is. That's not what our radius is. And they said they wanted us to find the radius of the circle. So this x right here is 1.875. Well, all we do to find the radius is add 3 to that. So the radius is 4.875 feet. Sorry, this video, when I made it the first time, it was right at about 50 minutes. It's about 4 or 5 minutes longer this time. 51. Sorry it's longer. I know you don't mind because you wanted to hear my lovely voice for as long as possible since this is your last assignment. And sorry I screwed up on the first video and sent it out. But here it is. Have a great summer. And thank all of you who worked really hard during this time. I appreciate it. You made my life a little bit easier. And again, have a great summer.